Welcome to Sailing the Storm here on ENF Trade TV. I'm your host, Charmaine, and today we are joined by Tok Charles, Technical Design Engineer from Spirit Energy from United Kingdom. Hi Tok, tell us about yourself.
So my name's Tok Charles. I'm a technical designer at Spirit Energy. So Spirit Energy is a solar installer in the UK. We've been going for 15 years now, so we're one of the first in this industry back in 2010. Our job is to turn hopefully every roof in the UK into a revenue generating asset that's producing electricity and saving the homeowner or the tenant money.
That's great to hear. Now let's dig into the project that you want to share with us. There's always that project that truly stretches a company's capabilities, unity, and perseverance. So for Spirit Energy, can you describe that standout project and explain what made it particularly difficult?
Standout project for us was Cobham service station. And I think that the biggest challenge, there were two big challenges. The first was the fact that it is the busiest service station in the UK. So they get over 6 million visitors every year. And so that means we're installing pretty much 20 tons of metal on a roof while there's hundreds of thousands of people coming in and out of the site. So we have to work on the roof safely without disrupting them and without disrupting the traffic coming in. But that was probably the tougher challenge. There was another slight challenge in that the roof is curved. So solar panels are rigid. They're rectangles, metal rectangles essentially, and they don't bend. So the second challenge was the curved roof, which was interesting.
Can you walk us through the setup and the key technical requirements of this project?
So the panels used were 450 watt modules, and then we paired those up with, I believe it was 2 or 3 Solis inverters. In total, it's about 360 kilowatt peak system consisting of 810 solar panels. 96% of the solar generation is going to be used by the building. And they're expected to save the service station about £80,000 in the first year on energy bills.
Okay, so you just mentioned the generated power. Now I want to know, what made you decide that 368 kilowatt peak is the number, not more, not less?
There were two limiting factors here. One was budget and the other was roof space. So ideally, if you've seen the drone shot of the system, we've covered the main roof with solar. As much as we feasibly can. You can't maximize every square meter of roof space because you need to leave room for maintenance. People need to be able to walk to access the panels and access other parts of the roof for general maintenance. So we filled as much of the main roof as we could. There's a second part, which is a hotel roof, which we didn't put panels on, and that was more of a budget limitation to the best of my knowledge. But that may come in a future phase 2 down the line, and battery storage might come down the line as well.
All right, so you mentioned earlier that the roof was curved and that there were HVAC units, Mansafe line, and pretty strict fire regulations to work around. So talk in plain language, what were the biggest roof and design challenges? And which one among all of this came closest to breaking the plan?
The big challenge is the fact the roof's curved, because usually a solar system, you can, on a straight roof, you can just fill it full of panels. You leave a gap every so often for maintenance. I wouldn't say it came close to stopping the project. There was nothing really major about this project that would say, no, we can't do this. There was just a few technical challenges, like the curved roof, like the millions of people driving in and out. So for example, one challenge we had was we delivered the panels directly to site. They're dropped off and we've got a telehandler there to lift them to the roof, but we have to schedule the panel deliveries around when the McDonald's are getting their deliveries of food and when the service station's stocking up on supplies. There's loads of huge lorries coming into this site every day to drop off supplies to the service station. So we just had to schedule our deliveries and our telehandler work around their deliveries so that we're not disrupting them.
Okay, Tok, can you walk us through how you manage installing all those 20 tons of Trina solar panels from start to finish?
So with the lifting to the roof, we used a telehandler. So we do everything in-house. So a few of our installers are fully licensed and certified to operate a telehandler in a public space. So they were using it. Obviously, we get the panels delivered to site, take them off the back of the lorry, and be careful to coordinate with the service station so we're not disrupting them. And then we lift them up to the loading bay. That's how the lifting worked. The other thing that happened was the scaffolding that was done at night. Again, to avoid disruption to the service station. So the scaffolders had to lift everything to the roof themselves because the telehandler wouldn't have been able to do that. But yeah, that's what we did with the lifting.
For a site that cannot really go dark, what was at stake when you had to flip the switch? And how did you do that? How did you engineer for zero disruption?
Yeah, so that was a really important part. You're absolutely right, because it's a live site 24/7, busiest service station in the UK. So you have to keep it running. I believe from memory, it was about the 1st or 2nd of October, 2025. So it was planned for a while in advance, pretty much planned before they even agreed to go ahead with the panels, because it's such a key date. It was set for a time where the data showed the service station is least busy. So we looked at when the service station is occupied and when it's least occupied, and realized that was about 1 a.m. So as few people as possible are disrupted. Now, obviously, the businesses were still going. So actually what we've done is connect the solar system into what's called the landlord supply, which powers things like the toilets. And the McDonald's and the businesses are on separate electricity supplies. So they weren't impacted. We're just powering the landlord supply. So the toilets turned off for a few hours, but that was it.
Tok, based on our research, you added extra safety measures, not required, but chosen for long-term risk reduction. Why? Why did you spec in the safety systems that most clients wouldn't ask for?
Solar is a 25, 30-year investment. So it's really important to design the system so that it is going to last 25, 30 years. It's worth investing in certain measures so that the investment's going to uphold. So two things we did. One was actually fit a Mansafe system so that we don't have to put scaffolding up, because scaffolding is very expensive. So if you need to access the roof to swap a panel, if something breaks, for example, you don't want to fill the roof with scaffolding. So we installed a Mansafe for that reason. Another thing we did was use a product called Arcbox. Solar panels are connected together in a string. And at the end, they're all sort of daisy chained together. And at the end, there's one central connection. The solar systems are very safe, but if there's one thing that is a fire risk, it's that central connection. So we added in a product called Arcbox, which covers that connection so that if it were to catch fire for whatever reason, it will burn inside the Arcbox and it won't risk the building or the solar system. It can easily be replaced.
Every site comes with its own rules and limitations. Now, how do the local regulations, load limits, space on the site, and utility requirements influence the final design of the system?
On the structural loadings, we've done a technical and a chartered structural survey for every single system, because you've got to be confident the roof can take the weight. So what we do there is take the structural measurements, work out how much weight we're going to add to the roof, and then get them checked by a chartered surveyor to be confident the roof can take the weight, essentially. So the structural wasn't an issue, but obviously it's something we always check. Another interesting challenge we had was actually designing the system. Because of the curve and because it's an odd-shaped roof, you can't just measure it on Google to work out how many panels will fit. So we actually sent a drone around the building to measure each part of it before we did the design, so that we can be confident that we know how many panels will fit.
For environmental factors like heat, dust, or hail, did you have any considerations on these things in terms of engineering and material choices?
So it was installed in September, so it was just coming out of summer, starting to get cold. So that wasn't an issue. Something important to think about is hail, as you say, because the solar system has to last 25 years. At some point in that 25 years, you're going to get some pretty bad hailstorms. So you have to make sure that you use panels that are certified about heat. So the Cobham service station roof is a dark roof, which can get quite hot in summer. So solar panels in the summer the actual panel itself can get up to a temperature of 60, 70 degrees Celsius. And panels are less efficient at that heat than they are at 20 degrees. 20 degrees is about optimal, but 70 degrees is not optimal, and panels perform less well at 70 degrees. So you have to pick a panel with a good temperature coefficient so that it's performing as well as it can in hotter temperatures.
Your crew were on 7 a.m. to 7 p.m. shifts and finished the job in almost half the expected time. So what did you do practically to keep the quality high and the team safe and motivated while still pushing that kind of speed?
The answer is they're very hard. Well, this is why we use in-house installers, because it gives us the ability to say, guys, are you able for the next? We've got a really important project. It's a really busy site. By using in-house installers, we can say, are you willing to work longer days for a few weeks to get this done? And of course they'll say yes, and they've worked with us for a very long time, and they're highly trained. So that's one of the advantages we have there. Quality control is just second nature. It's the most important thing. So our head of installations, who's been with us since 2010, will check over all of the work regularly to make sure he's happy with it. So he was doing that, and we're pleased to say that we didn't notice a drop in quality because our guys were working longer hours. So that was great. In terms of the other thing was doing the scaffolding at night. That's the bit we don't do in-house, is the scaffolding. So we've worked with a local scaffolding company for over 15 years, and we said, look, are you able to install this overnight, because it's a high-profile building, and they were happy to do so.
You actually touched on my next question already. How did having an in-house team help? But from an efficiency point of view, Tok, how does that compare to using multiple subcontractors, which like most of installation companies is doing right now?
By going in-house, you get ultimate control. So you only hire people that work hard, that can install to a high quality, and who are reliable and trustworthy. So going in-house is much more consistent, much more reliable. You do your own training, you have your own quality controls, and we found it works much better for us. And that really helps on this project, because obviously we can work 7 a.m. to 7 p.m. We can be really meticulous on the quality control. We know exactly what our guys are doing at all times, and it works really well.
Shifting gears to leadership aspect, how has this particular project influenced your approach to other challenging installations in the future?
Well, you learn. This is one of the first projects we've had to do where we're working sometimes at night, so we learned a lot there. And this is probably the most high-profile building that we've done as well, in terms of traffic coming in and out. So we learned a lot with having to work around the building to make sure that all the deliveries coming for the businesses aren't interrupted. We had to coordinate all of that, and we learned how to manage overnight, which we've done before, but not loads. So that's really valuable, because when we come to do high-profile buildings in the future, say airports, for example, where there's loads of foot traffic, we know how to manage that well. So
looking back, is there anything you would do differently if there's like a magical time machine that will allow you to?
Nothing major. We've been doing this for 15 years, so we know how to design and install a good solar system now. I think it will be interesting to see if they come back for a phase 2 to fill more of the panels. There's nothing I think that we should really, oh God, we should really have done that better for this project. It all went quite well because we planned it out well.
With all the ups and downs in the industry, so from your personal point of view, Tok, how would you describe your journey in solar so far? And with everything happening right now, where do you see things heading next? In terms of where I see the industry going, I think the big opportunity is in business roof space. Every business has a roof. Every building has a roof. Solar is really a good investment now. It's cost effective, it pays for itself, it stacks up well as an investment compared to other things that businesses could use their cash for. So I think the future is hopefully national adoption of solar. Every roof has solar panels on it, and hopefully the government can help that. And that's a wrap. Thank you so much, Tok, for being a guest today in our show. Thank you. This has been Sailing the Storm only on ENF Trade TV. We'll see you on the next one.